Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you should have x minus 15 times x minus 15, or you can write it as x minus 15 squared. For the math knowledge question, it tells us AB and DE are perpendicular to BD. That's why we have a right angle here and here. And AE and BD intersect at C. Which of the following is true about any of our figures? All that we know is that they are going to be similar triangles. We don't know anything about the side lengths, but we know that this angle here and this angle are going to be congruent, which means that these two have to be congruent as well. And so since we have all three angles congruent, that means we have similar figures. But we don't know that anything is congruent or bisects. So that's all we can say. So we're going to be looking at lesson 43 today. We're going to be looking at chords, secants, and tangents. So this is all related to circles. So hopefully you'll understand how chords, secants, and tangents are all related after this lesson. So a chord is a line segment whose endpoints lie on a circle. So the chord would be AB. It has endpoints that are on the circle. So here's your chord. A secant is a line that intersects at 2 points. So CD is a secant because it's a line that crosses the circle at 2 spots. And then a tangent is going to be in the same plane as the circle, and it only intersects the circle at 1 point. So this is our line that is tangent, line FE, and it is tangent at this point here. So E is the point of tangency. So we're going to identify 3 radii and a diameter, 2 chords, and then a tangent and the point of tangency. So one of your radius could be GO, one could be FO, and one could be JO. And the diameter would be JG, because it's the only one that goes through the center and has endpoints on the circle. 2 chords, one of them is HG. The other one is JG, which is your diameter, and that is allowed for your diameter to be a chord. A diameter is a special type of chord. Now we're going to look at the tangent. The line that's tangent is going to be line LM, and the point of tangency is going to be point K. So I should have line over L and M. So that would be your answers for that one. Now we're going to look at a theorem 43.1. If your diameter is perpendicular to a chord, then it has to bisect the chord and its arcs. So if we have a circle and you have a diameter here and it's perpendicular to the chord, that means that this segment is congruent to this segment, and this arc and this arc are equal. And then theorem 43.2 says if a diameter bisects a chord other than the diameter, then it has to be perpendicular to the chord. So if we have a diameter and we know that it bisects a chord that's not the diameter, then this has to be a right angle. Okay, so we want to look at these two. Find the length of Y. Since we have a right angle here, these two segments have to be congruent. So Y is going to have to equal 5. on this next one, since these two are congruent, that means that this angle has to be a right angle. And so this angle would equal 90 degrees. Okay, looking at part C. So the first thing you want to do on these is to draw the figure. So you're going to draw a circle, and you always want to draw a diameter and then the chord. You want them to intersect. So it tells you the diameter is 16 and the chord KM is 10. So that means that this side here is 5 and this side here is 5. And it wants to know how far is KM from the center. So what is the distance here? So we'll label that X. We can make a right triangle here because we know this is a right angle. And if the diameter is 16, this is a radius. So it would be 8. And we can use Pythagorean theorem on this triangle here. So 5 squared plus x squared would equal 8 squared. So x squared would equal 39. And then it says to the nearest hundredth of an inch. So you're going to take the square root of both sides. And that would give you 6.24 inches. So that's what you can do on that one. On these, when you're dealing with circles, you're pretty much always going to try and make a right triangle somehow for these. Okay, so let's look at the next one. Theorem 43.3. So this theorem says a perpendicular bisector of a chord is always going to contain the center of the circle. So if you have a circle and we know that these bisect each other, or it bisects it and is perpendicular, the center is going to have to be somewhere on this line based on this theorem. So looking here, what is the value of x and what is the length of chord ST? So we know that 3x minus 6 is going to have to equal x plus 8 because the chords are the diameter and the chord are perpendicular. So 2x minus 6 would equal 8. So 2x equals 14. X would equal 7. And then if you plug in, this side length is going to be 15. So this side is also going to be 15. So the length of ST is going to be 30. So that would be your answer for that one. All right, so theorem 43.4. In a circle or in congruent circles, if you have chords that are equidistant from the center, that means that they are congruent. And if you have congruent chords that are equidistant from the center of your circle. So let's look here. If here's the center and you have a chord here, and let's say this is 5 inches and then this is another 5 inches and you have a chord, that means that these two chords have to be congruent. And then it says if you have congruent chords, they're going to be equidistant. So if we know these chords are congruent, then that means that this distance has to be the same as that one. So looking here, we want to find the length of SR. So we know that these two pieces are congruent. So that means that whatever the length of SR is, it's going to be the same as the length of QP. And then if you look, we have a right triangle here. And so we can find the length of TP there. So x squared plus 5 squared is going to equal 9 squared. So x squared plus 25 is going to equal 81. So that means that x squared is going to equal 56. And so you can take the square root of that, which is 7.48. And then we're looking for the whole length of the chord. So 2 times that would give you 14.97 units. So that's how you could do that one. We're going to look at another example. We have two identical circular pipes. Each have a diameter of 16. And we know water is flowing 2 inches below the center of the pipes. So here's the center, and 2 inches below, we know we have water. So this is all our water. And then we want to know what is the width of the water surface in the pipes. So we're looking for the length here. They told us that the diameter was 16, so that means that this radius would have to be 8. And then we can find our x value here using Pythagorean theorem. So x squared would equal 60, and so x would equal the square root of 60. Which is 7.45, and then if you multiply that number your calculator gave you by 2 to find the total width, you would get 15.49 inches. And it says what can be concluded about the width of the water surface in both pipes? Well, they're going to have to be the same because we have congruent circles and the distance from the center is the same. So the width of the water surface is going to be the same in both pipes, and it's going to be 15.49 inches. All right, so let's look at this practice problem. Y'all see if y'all can identify the lines, and then we will go over it. So one line that they give us is this line M. This is a tangent line. Another line that they give us is line L, which is a secant line. And then they also give us segment FG, which is a chord. So that should be how you identify those. Looking at this next one, y'all try these by yourself, and then after y'all are done, you can go over it. So A will be 7, because these two pieces are congruent because of this right angle. And then if these are congruent, that means that X is equal to 90 degrees. So that would be your answer for that one. Looking at this next one, we want to prove the first part of theorem 43.1. If a diameter is perpendicular, then it bisects the chord. So we're going to do a 2-column proof. We're going to start with our statements and reasons. And I have our prove and given backwards. This is the given, and this is what you're trying to prove. So if y'all think that y'all can do this one by yourself, y'all can go ahead and try that, and then we can go over it after y'all have unpaused the video. So your given is going to be that CD is perpendicular to EF. And the reason is going to be that it is the given. From there, we know that angle CME equals 90 and angle CMF equals 90. And that's from definition of perpendicular lines. So both of these have to be equal to 90 degrees. Then we're going to draw your radii, CE and CF, so that we can make some triangles here. And the reasoning there that we can just draw them in is that 2 points determine a line. You could also say any 2 points are collinear. That would work as well. Then from there, we know that these triangles are right triangles. So triangle CEM and triangle CFM are right triangles. And that's just from the definition of a right triangle, because they have a right angle. After that, we can say that CM is congruent to CM by the reflexive property. And EC and FC are congruent. And that's because they are both radius, or they are both the radius of the circle. And so all of the radiuses, all of the radii of the circle have to be congruent to each other. And that just comes from the definition of radius. So that means that our two triangles are congruent. So triangle CEM is congruent to triangle CFM. And that would be by the hypotenuse leg right triangle congruence theorem. And if they are congruent, that means that EM is going to have to be congruent to FM. And the reasoning there is CPCTC. And I'm realizing now that this should say EM. No, that's right. No, it is. It is right. Okay, so these are congruent here, which means that CD has to bisect EF, and that's from definition of a bisector. And so that would be your proof for that one. Okay, so hopefully y'all were able to get most of that part right by yourself. If you're still having trouble with two-column proofs, go back to that video and rewatch it on the two-column proofs lesson and see if maybe you can work through some of those that are a little bit easier by yourself. And then maybe work on some more homework questions that you've been having trouble with. Go back maybe 15 lessons and try a two-column proof from there and see if you're able to get them right. They have to, you have to work on those. They're not going to come to you just automatically for the most part. All right, so let's look at one more practice problem. Actually, we have another one after this one. So let's see if y'all can do this one by yourself. So we have a circle and a chord that is 5 inches long. What is the distance from the chord to the center of the circle? So if the chord is 5 inches long, that means that each side over here and here are going to be 2.5, because that's half of 5. And it said the diameter was 9, so the radius would have to be 4.5. So you're going to use Pythagorean theorem. And so x squared plus 6.25 equals 20.25. And then x squared would equal 14. And so x would be the square root of 14. which would be 3.74 inches. So that's the distance for that one. Let's look at one more practice problem. Y'all try this one all by yourself, and then after you've attempted it, we can go over it. So we have a circle, and the water makes a cord across the pipe that is 15 inches long. How close to the center is it? So we're looking for that distance. Cut the 15 in half to make 7.5 and 7.5. And then the diameter is 16, so that means that this radius would be 8. And so again, we can use Pythagorean theorem. So you're going to have x squared plus 56.25 equals 64. And then if you subtract, x squared is 7.75. And if you take the square root, x will give you 2.78 inches. Oops. And so that would be your answer. So hopefully you're able to get most of those right. If you're having trouble drawing the pictures, you're always going to try and make a right triangle. So that's what you're trying to get to, some kind of right triangle. So let's look at the challenge question. You want to construct a circle with 3 non-congruent chords and their perpendicular bisectors, and then the perpendicular bisectors converge at point P. How does theorem 43.3 prove that P is the center of the circle? So y'all try this one by yourself, and then unpause the video and I'll go over it. So we have a circle here. And we have 3 non-congruent chords. So here's one chord with its perpendicular bisector. Another chord go here, and its perpendicular bisector would maybe go right there. And then another chord of a different length, we'll say is right there, and its perpendicular bisector looks like it's going to go right here. And they converge at this point P. How does theorem 43.3 prove that P is the center of the circle? Well, the perpendicular bisectors of chords all contain the center of the circle, according to that theorem 43.3. So all 3 of the lines that I'm about to draw in green, this line, and this line all have to be diameters, which contains the center of the circle. And so since they all intersect at that one spot, that has to be where the diameters intersect, which is the center of the circle. So P has to be the center of your circle. Okay, so that is lesson 43. Make sure you do your homework tonight so we can go over your questions